Hello friends, welcome to our YouTube channel. Now, in this lecture we are studying about the conical pendulum. Okay, we know that the simple pendulum it is moving to and fro about its mean position. Now, for the circular motion we are dealing with the conical pendulum. So, conical pendulum means what? It is in the equilibrium with the vertical direction and continuously performing the circular motion in the horizontal direction. Okay, so this is shown in the diagram here. Okay, so it is tied with a thread with a rigid support in the upward direction. Okay, now the length of that thread it is L, and the bob means the object it is performing the circular motion along the horizontal, means it is continuously in contact with the rigid support, but it will not perform the to and fro straight line motion, it will perform the circular motion. So it will made a cone like structure, hence this is called as a conical pendulum. Okay, so here we are going to derive the time period for this conical pendulum. So for that time period we require this diagram. Now let here the mass of the bob it is m. So weight of the bob it is mg in the downward direction as shown here, and it has one more type of force that is towards the rigid support, that means along the string of the pendulum, and that is the force which is nothing but the tension. So here it is represented as F. Now this F is resolved into two components, along the horizontal direction and along the vertical direction. Okay, so along the vertical direction this F is resolved as F cos theta. आपण कधी पण एक वेक्टर क्वांटिटी असेल तर त्याचं रिझोल्युशन कसं करू शकतो हे बघितलेलं आहे. So here F is a vector quantity, so we resolve this into two components. Along the vertical it is F cos theta, and along the horizontal it is F sin theta. Now what is theta? Theta is the angle made by the string with the horizontal vertical line of the pendulum. Okay, pendulum जर मोशन मध्ये नसेल, त्याची जी वर्टिकल लाईन असेल, दॅट मीन पोझिशन इक्विलिब्रियम पोझिशन, त्याच्यापासून कोनिकल पेंडुलमने रोटेट होते ना किंवा होरिझॉन्टल हे सर्क्युलर मोशन मध्ये असताना जो अँगल फॉर्म केलाय बघा डायग्राम मध्ये वरच्या डायरेक्शनला दाखवलेला आहे, दॅट इज द अँगल थीटा. ओके, नाउ लेट r is the radius of that circular path performed by the conical pendulum, and h is the height of the conical pendulum. म्हणजे at the equilibrium position h will be the height, L is length of the string. So observe that here we are getting a right angle triangle. Okay, inside with angle theta, here it is right angle triangle. So from that right angle triangle we can apply the trigonometry and we can find cos theta. Okay, so what is formula for cos theta? It is base divided by hypotenuse. Okay, so observe this diagram. Here base it is the h and hypotenuse is the L, length of the string. So cos theta is h divided by L. So from this we will find h is equals to L cos theta. Okay, we'll keep as it is. It will be useful for the later on concept. Okay, so here next we start with the expression of this conical pendulum. Okay, so what we observe in the diagram, we will write here that L, what is L, what is theta, what is the mass mg, its direction and the force acting on this. Okay, now here the tension F is a tension F can be resolved into two components as we discussed with the diagram. It is F sin theta and F cos theta. Okay, so horizontal is F sin theta and vertical is F cos theta. Now how they are balanced? So first we'll discuss with the vertical direction, F cos theta. Now remember the diagram, F cos theta direction is vertically upward direction and downward direction is the weight of the bob. So we know that in equilibrium the forces which are exactly opposite in direction, they are balanced. So here we are balancing this F cos theta and mg. So F cos theta is equals to mg. These are balanced. This write it as a equation number 1. Okay. Now for the horizontal force. Now horizontally we are getting here F sin theta. Okay, towards the center of that circular path, F sin theta. And we know that whenever there is a circular motion, there is a centripetal force acting on the object. So here this bob will also experience the centripetal force. So this F sin theta means horizontal component will be balanced by the centripetal force mv square by r. So we are writing that F sin theta is equals to mv square divided by r. Write it as equation number 2. Okay. Now divide equation 2 with equation 1. Okay. So equation 2 in the numerator and equation 1 in the denominator. So what we will get here? LHS F sin theta divided by F cos theta. And RHS mv square upon r divided by mg. Okay, हे सॉल्व करायचं आपल्याला. नाव एफ गेट कॅन्सल आउट. टॅन थीटा साइन थीटा अपॉन कॉस थीटा विल बी टॅन थीटा. LHS बघतो सध्या आपण. ओके, एफ गेट कॅन्सल. साइन थीटा अपॉन कॉस थीटा इज टॅन थीटा. So LHS is there tan theta. In the RHS only m will get cancel. बाकी काही त्याच्यामध्ये चेंज होणार नाही. So m will get cancel. After solution of this we'll get here v square divided by rg. Okay, so we are getting equation here tan theta is equals to v square divided by rg. Now find the velocity v. What is v then? Cross multiplication rg tan theta, it is v square. So v is equals to square root of rg tan theta. Okay, this is the next equation. Now we know that the relation between the linear velocity and the angular velocity. Why we are using here? Because the bob or the pendulum performs the circular motion. So here we required the linear velocity and the angular velocity relation that we studied earlier. V is equals to r into omega. Okay, so इथं circular motion आल्यामुळे आपण हे replace करणार आहे. And we have seen in the earlier equation that v is equals to square root of rg tan theta. Okay, so v म्हणजे r omega आहे. So substitute this in that equation. So it will become as r omega is equals to square root of rg tan theta. Okay, हे आपण सगळी प्रोसेस करणार आहे to finding the time period of the conical pendulum. Okay, so r omega is equals to square root of rg tan theta. Now solve this. Okay, we are just simply doing the some steps. Now squaring both the side, LHS will become r square omega square and LHS becomes r square omega square and RHS becomes square root जो होता तो स्क्वेअरिंग केल्यानंतर रिमूव्ह होणार आहे. इट इज rg tan theta only. Okay, so this is equation number 4. Now observe the diagram. In that diagram we can find tan theta also. त्या डायग्राम मध्ये जो राईट अँगल ट्रायंगल होता जिथे आपण cos theta फाइंड केलेला, we can find tan theta also. Tan theta means what? It is the perpendicular divided by base. So we'll find here r divided by h is tan theta. Okay, so I have written here, you observe the diagram and then confirm it. Tan theta is equals to r upon h. So substitute this value of tan theta in equation 4. याच्या आधी जे आलेले होते that is equation 4. So substitute there, we are getting here r square omega square LHS as it is equals to rg tan theta जो होता त्याच्यामध्ये tan theta फक्त आपण रिप्लेस करायचा. So rg into r divided by h. So we are getting here r square g divided by h. So r square omega square is equals to r square g divided by h. Now both side there are r square, so they will cancel out. So remaining term is only omega square is equals to g by h. Omega angular velocity, or we can write omega is equals to square root of g by h. Now we know that the angular velocity, it is related with the time period. How it is related? Omega is equals to 2 pi by t. Okay, now replace this omega as 2 pi upon t and RHS remains same, square root of g by h. Now we are going to find the time period t. So inverse this equation. T upon 2 pi is equals to square root of h upon g. Okay, now the next term what we are doing here, we are just doing that 2 pi क्रॉस मल्टिप्लिकेशन करून पलीकडे घेतलेलं आहे. सो 2 पायचं मल्टिप्लिकेशन पलीकडे केल्यानंतर टाइम पिरियड इज इक्वल्स टू मीन्स जस्ट RHS आपल्याला थोडासा सिम्प्लिफाय करायचं आहे. वी आर गेटिंग द time period. T is equals to 2 pi square root of h upon g. Now remember that in the diagram we already have finding the h. h is equals to L cos theta. हे आपण ऑलरेडी डायग्राम ज्यावेळेस केलेलं होतं तिथंच सॉल्व्ह करून घेतला होता. सो रिप्लेस द व्हॅल्यू ऑफ h देअर. सो टाइम पिरियड t is equals to 2 pi square root of L cos theta divided by g. This is nothing but the expression for the time period t, and this is for the conical pendulum. Okay, so here we required that diagram. Here we are applying just simply cos theta tan theta from the right angle triangle and applying the concept of the v is equals to r omega, so we can easily find the time period. Okay, now the factors which are affecting the time period of the conical pendulum, I have shown here that factors. So you will observe that the number one from the formula only. ही फॅक्टर्स कशावरून लक्षात ठेवायचे, फॉर्म्युला जो आपला आलेला आहे तोच फक्त फॅक्टर्स जे आहेत ते मेन्शन करतो. टी इज इक्वल्स टू 2 पाय अंडर रूट एल कॉस थीटा अपॉन जी होता. ओके, सो टाइम पिरियडच्या एल लेंथ ऑफ द पेंडुलम, त्याच्यानंतर इट इज अँगल कॉस थीटा होता, दॅट मीन्स अँगल ऑफ द conical pendulum, and the last one is the acceleration due to gravity g, L cos theta divided by g. So time period of the conical pendulum, it depends or it will vary with these three factors only. Okay, if we increase the length of the pendulum or that thread of that length of the thread, then there is change in time period. Angle which is made by the conical pendulum, if it is changing, time period will change. Acceleration of gravity, if its value is differ at different places, then if we are conducting this at different places, then we are getting the different time period. So these are the factors which can affect the time period. Okay, so this is about the conical pendulum. Hope you understand this. If you have any doubt, please comment here, like our videos, share it and subscribe.